Hi, I'm Anna Hoffman, and welcome to this Learn Live session at Microsoft Ignite. Today, I'm joined by Davide Mauri. Davide, how about you introduce yourself?
Yeah, absolutely. Hey, Anna, Davide Mauri here, Azure SQL PM in, of course, the SQL team. And yeah, I'm mainly focusing on Azure SQL and developers and IoT today. So looking forward to the session.
Yeah, it's going to be a great session. For those of you joining us today from wherever you're streaming from, we have an awesome session planned, and this is all based on a Microsoft Learn module, which is called Deploy IoT Solutions with Azure SQL Database. So over the course of this session, if you haven't joined us on Learn Live before, what we're going to be doing is stepping through the module with you, and there are also free hands-on exercises that we'll complete live during the session, and we encourage you to go get hands-on for free after this session. Now, during this session, we're going to show you all how to create scalable IoT solutions with Azure SQL Database and how to use a template provided for many IoT use cases. Now, fun fact behind the module is that we actually have a lot of customers that are asking for this sort of thing. So they want to do IoT with Azure SQL Database, and we've basically created a template where you can get all the best practices and all the tips and tricks in one place. So now with this Learn module, you get hands-on for free, try out the template, and then afterwards you can tweak the template to actually use in your own IoT scenario. So that's what we're going to show you all today. We want to remind you all that this is live and interactive. We have moderators and subject matter experts standing by to answer your questions. So please do use the chat to engage with us, whether it's saying hi and let us know where you're from or asking questions. And of course, there will be knowledge checks. So Davide hasn't seen
Mhm.
these questions yet, so we'll see if he's able to answer them
Oh man,
correctly.
oh man. Now I feel the pressure.
Yeah, you should feel the pressure, but maybe your viewers are going to help. And so maybe we'll let you
Yeah,
see
yeah,
what they say, and then you can go from there.
exactly.
Awesome. Okay, so let's get right into it. So I wanted to start by giving like a little bit of an introduction. As you all know, many organizations are kind of investing in IoT to increase their operational efficiency, deliver better customer experiences, increase their level of security, enhance workplace safety, and many other things. So we wanted to look at one example. So let's assume for this example, you work for a distributor, and your role is to essentially manage the logistics of shipping goods between different warehouses. Now, these goods are being shipped by a fleet of several thousand trucks. So you have a lot of trucks that you're trying to manage and maintain, and it's your responsibility, or I guess our responsibility, to make sure they show up on time. So one of the things you're looking at implementing is this IoT solution so you can monitor your devices wherever they are. And if there's any irregularities, so for example, if you're monitoring the temperature and the temperature of the engine goes way up or way down, then maybe you want to schedule a maintenance to kind of avoid any delay. So that's kind of the scenario we're going to walk through today. And let's get into some architecture. So Davide, I think
Yep,
maybe some people are familiar with IoT, maybe not, but it would be great
yep,
if you could take us through like a typical IoT solution and then
yep.
an IoT solution in Azure.
Yeah, absolutely. And so let's start with this slide here. As you can see, an IoT solution is not exactly I wouldn't say it's complex, but maybe it's not like the easiest thing you can do. And also that's why we created this Learn module, right? To make sure that even someone who is really starting right now in IoT can basically have start with the right foot and have all the things in the correct places, use the right technologies for example for this demo, because as you can see, there's quite a lot of moving parts, right? So we start with the sensor, of course, and some what we call the edge device that are physically or the thing that we want to monitor, like the machinery in this case, the truck, for example, or whatever, a container, or something that is on board, like for example, using some edge device that we also provide. And then we want to have this data moved to the cloud, of course. So we need a cloud gateway. And the cloud gateway is a kind of a service that allows both bi-directional communication of course, from the device to the cloud, but then also from the cloud to the device, because maybe once you learn the device is reporting some data, you want to change something on the device, or maybe the device is connected to some machinery and you want to change the way that machinery is configured, right? So you need to have a bidirectional communication. And then this is where the things start to get pretty interesting, I would say, because usually the data is split into streams. One is properly a stream, so we want, the IoT solution typically needs to process the data while it's being produced. So this is tricky because literally you can't query and the data and get the same result, because the result will keep changing. It's like a flow, right? So that's creates some challenges, but likely we have the answer to that. And then you also have, at the same time, you want to stream, you want to process the stream, but at the same time, there are something you can't process on the stream. Like, for example, let's say you want to create a machine learning model that predict if something is going to fail, or what is the expected value you should get from your IoT device. Of course, you need to do some batch processing, and you need a lot of data, maybe the historical data, in order to generate that machine learning model that maybe can then be called by the stream processing, but definitely that is not something you can do on the stream. You need to have this batch processing that usually involves quite a lot of historical data, where you figure out analytical information, again, predictive algorithm, and so on. And depending on where your data is coming from the stream or from the batch processing, you may end up in two different storage. One is called the warm storage, which is typically associated with the stream processing, where you want to basically put the data and immediately query it. Like, for example, you want to update a dashboard. So you need to have the last, 1 hour of data, for example. So we need to actually write the data very quickly in order to be able to keep up with all the data coming in, but also be able to aggregate and analyze data so that it can, feed, for example, a report or a dashboard. And that's a warm storage. And then we also have the cold storage that instead used by the batch processing, where you offload everything, like all the data, even that data that maybe is not used for the dashboarding, but is some data that maybe is needed for the machine learning or by the data scientist to better understand what's happening over time. So you want to also have the cold storage. And again, then the consumer of this data can be, as I said before, a dashboard or a report, or data scientist using, for example, Spark or Synapse or anything that we provide. And this architecture is somehow well known. There are variations of that. One is called, this is the IoT architecture, but basically the roots are in two architecture called Kappa or the Lambda architecture. So if you are familiar with those architecture, you probably are familiar already with the IoT architecture in general. And that's it. Now, it may not seem so simple, but actually is at the end, even because Azure provides quite a lot of services that really fits well in each of these services or section I just described, right? So yeah, we have, as you can see here, laid out a possible solution, right? Because I can imagine probably 100, and I'm not kidding, because before joining the Azure group, the Azure SQL group, I was doing exactly this, stream processing. And I figured out that using Azure with all the possible combination, we have probably 100 ways of implementing exactly this architecture, depending on what we need, right? Someone needs, maybe prefer to use Spark. Someone else, like in this case, prefer something even more easier, but yet very powerful, like stream analytics. So in this case, we decided to go full PaaS, so full platform as a service, where we started, of course, we start with the device on your truck, for example, and for that you can use the IoT Edge, or for communicating with the cloud, in this case we are using IoT Hub. And IoT Hub is basically a way to ingest data and at the same time also communicate back with the IoT devices. Behind the scene uses Event Hub, for those who are familiar again with the entire and overall architecture. But then we ingest data using IoT Hub, and then from IoT Hub you can do several things. So we decided to do things here. The first one is use Stream Analytics to do the stream processing, so querying and aggregating and analyzing the data while it is flowing, even before it reaches the final destination. So we can change data, I would say, in near real time, or query the data near real time. And so following the stream processing path, we can, for example, feed a UI a report or a Power BI dashboard, or we can even monitor what's happening and raise some action and execute some action or raise some alert. For example, you can connect it to Logic App so that if something is out of the range you want it to be, some value like a temperature, you can notify someone, for example. And everything, of course, is managed and secured using Azure Active Directory. So everything is secure. You don't have to worry about, password and other stuff that may be a little bit, delicate to manage. But that for the streaming part. Of course, we also have the cold path, or where we want to do the batch processing. And for that, here we have chosen to use Azure Function app, which can be invoked as soon as data is coming in from IoT Hub. And then we can execute an Azure function that does some basically extra transformer load or some processing. And then we decided to store into the warm path. And this is, I would say, the key point here, because it enables us to do interesting stuff using Azure SQL. Azure SQL is really great for IoT solution, as we will discuss, because it has a little bit of everything. And in IoT, as you can see, there's a lot of moving parts to aggregate them, different type of data, different needs, so quite a lot. And then we can store data into the storage for example, for a storage, and for example, use machine learning to build a model on top of the data we save. So it may seem a little bit overwhelming at the beginning. It's really a lot of technologies, a lot of moving part, but once you see it laid out and running, it's like, wow, this is magic.
Yeah, no, and it definitely seems like we have a bunch of these services created for you, so you can do these things a lot easier. So I think that definitely helps. Davide, we got one question I thought was really interesting, and it's from a fellow Californian, so I'm going to ask it. Matthews from California says, machinery that might need a faster response for data, for example, a robot or a car cannot wait until the data is analyzed. How can we get those learnings at the edge or before the cloud gateway?
That's very interesting. So that's a very good question, because it's kind of becoming common to move compute to the edge, exactly to have a super low latency in terms of processing. So one way we can do that is, for example, using Azure SQL Edge, where you can actually run Azure SQL on the edge and basically have the stream processing on the edge, so you can do some processing before you send data to the cloud, maybe not only for a latency kind of challenge or issue, but also to minimize the amount of network used, because if you are on a ship in the middle of the ocean, maybe bandwidth is not exactly like a gigabyte bandwidth, right, that you have. So that's an option, and basically containerizing a lot of technologies can be containerized and pushed to the edge. That's how IoT Edge works mainly. So yeah, you can use Azure SQL there, then you can use your Python, for example, if you want. So plenty of choice to make sure that you do pre-processing on the edge, and only when you are happy with that, you send it to the cloud.
Yeah, definitely. And one thing I've seen a lot of customers do is they actually bring all the data into their cold path store and do some machine learning on it, or do some machine learning even in Azure SQL. And they take that model and they deploy it to, for example, an Azure SQL Edge device. So that's just one option that you could do. Matthews, I hope that helped answer your question. Definitely a reasonable question to ask. Now we're going to move into talking a little bit more about why you might choose Azure SQL Database, some of the reasons that it scales so well. So Davide, can you tell folks a little bit about how much it scales?
Man, I have a year or two. I can, tell many stories around how much we can scale Azure SQL. So let's start easy. First of all, we can go up to 128 vCores with M series, so pretty much, I would say. And up to 100 terabyte, because if you are, and this is important, the elasticity of this option, because if you are ingesting 1 million of rows per second, for example, well, data start to be pretty big pretty quickly. So the ability to be able to ramp up to 100 terabytes almost in a snap, it's super important. Then Azure SQL offer a high ingestion and low latency. Literally, you can ingest, megabytes and megabytes or million of rows per second with a very low latency, thanks to some technologies we will discuss later. We have secondary replicas, and this is really, really amazing. You can actually have a set of nodes where you can write into one node and the data can be read from another node, but that's another node, it's another compute. So you are not creating any kind of competition in using the same resources. So this means that you can have as many, report or mobile device reading the data that is actually being pushed in the database without any clash on constraint, for example. We have elastic database tools that allows you to create a sharded solution. Of course, we have batching in the sense that we can do batch processing, and this is a key feature of Azure SQL, where we can process a lot of data very efficiently in a very small amount of time. We have something that not many knows, because I guess it's a pretty niche, but when you do IoT, it becomes common requirement. We have tables that doesn't require locks at all to manage consistency between updates. And this means that you can have, millions if you want of concurrent query on the same table without having literally a lock. And so you have a huge concurrency here. We have cluster column store index that makes aggregation of data super fast, like really fast, like you cannot believe it. So queries that would otherwise take minutes take seconds or even less. So this is perfect for HTAP workload, which HTAP means hybrid transactional analytical processing, where you basically ingest data, but at the same time you need to query it to do some analytical processing. So this is perfect for IoT. We manage both relational data, of course, that's where we started. But also we expanded and evolved Azure SQL to handle JSON, to handle graph data, to handle geospatial data. So imagine, of course, IoT has geospatial data inside, right? Probably every device will send latitude and longitude, and you probably want to analyze it and say, okay, when a truck is within a geofence, or two trucks are too close to each other, send a notification, for example. That's pretty cool. And also we have temporal table. That's another, I would say, niche feature, but that really makes a difference when you learn how to use it. Temporal tables means every single change done to a table is tracked, and I can query the table saying, oh, show me the data like it was when it was, 3 days ago. So I have repeatable queries even if the data continues to change, and this is perfect both for auditing, but also to create BI solution. This is basically perfect to create slowly changing dimension. It's basically already done. So as you can see, many features that are super helpful for IoT. Yep.
Yeah, definitely. There's a lot in here. Let's see. We did get another question in. Mm-hmm. This is a good question. I'm gonna pass it to you, Davide.
So you need. I have to ask you to read it because for some reason,
sure.
Even if I refresh, I can see it. So yeah, thank you.
So Constantine says, anything in the pipe from your end that can help customers with guidance on how to pick the right combination of services for their scenario and the requirements.
Oh man,
it's a loaded question.
yeah. How to pick the correct technology? I think for me boils down to if you're working with a team, what the team is already comfortable with, and honestly, I think that's the beauty of Azure, right? And Azure offers so many options that any team can pick something that they are comfortable with and be sure to make a right choice, because today we decided to use Stream Analytics, right? But maybe someone is more comfortable with Python and Spark, and that will work as well too, right? So it depends, I would say, is the answer in the sense that the usual answer. But yeah, let's say that Azure will help you no matter what, because for example, just let's stay on Azure SQL that we know so well. We don't really make any difference if you are querying data using Python or Node or .NET, right? So you pick the language and the OS you want, and you just go for it. No need to change the way you work in order to be able to create your solution, right?
Yeah, awesome. Yeah, and Konstantin, hopefully that helps. I would also add, like, the template we're going to show you and what you're going to get hands-on with is a great starting point. So you can start here. It's maybe more simple than having a ton of other services involved. And then as you see the need for more services, you can kind of bring those in. So what we're going to do for this scenario and for all the exercises you're going to see is we're going to be using an Azure virtual machine to simulate a bunch of devices. So this is going to be simulating, remember, we've got a truck scenario going.
Yeah.
So this is going to simulate our device, our truck fleet of devices. Then we're going to have those fed into Azure IoT Hub. We're going to use an Azure Function to kind of help bring that data into Azure SQL Database hyperscale. So Davide is going to tell us all about some of the benefits of that later. And then at the very end, of course, we want to do some analytics on top of it. So we're going to do that with Power BI. So that's kind of the template architecture we put together for these exercises. Again, it's something we were seeing a lot of customers use. So I don't know, Davide, what do you think? Should we take a look?
I say you should get started, because I guess we don't have all the day, right? And there's a lot of stuff to to see, right?
Awesome. Okay, yeah. So we're going to go ahead and do the exercise in the module where we deploy the solution with Azure. We're going to step through all these things together. Hopefully everything goes as planned. We'll see.
We'll see. That's the beauty of the live, right?
Yeah, you'll be able to tell it's really live. So with that, let me hop over to my Edge. So what you can see here, this is the module. I just wanted to show you all the module. It's out here on Microsoft Learn, so you can go find it. And there are lots of a couple exercises and also some kind of more descriptive text. I don't know how else to say it, but it's going to take you through some of the things that Davide and I have been talking about. But for now, we're going to go straight into the first exercise. If you haven't used Microsoft Learn Sandbox before, what's so awesome about it is that you don't have to have an Azure subscription. You can just log in with some sort of Outlook or Microsoft account, and then you get a sandbox. And you can see that I have about an hour and a half left in my sandbox. Most sandbox are an hour to 4 hours. It just depends. This one is 2 hours long, which is plenty of time to get through everything. But what you can also see is I can use 20 sandboxes in a day. So it's going to be hard for me to actually run out of Azure services or credits.
That's pretty cool.
Yeah, it's definitely really cool. And Davide and I will share some other things we've done in this space at the end.
Yep.
But what you can see here is we've essentially used an ARM template. So here, the first thing you're going to do, I already did some of these steps just because they take a little while. But what we're going to do is we're going to generate a key so that we can connect to a Linux virtual machine from this Azure Cloud Shell, which is basically a way to interface with the Azure Portal and Azure resources. And once we've done that, we're going to kind of provide that key in PowerShell. We're going to have a SQL admin login. We're going to provide a password and our IP address. Now, the IP address is so that we can create a firewall rule so you can query Azure SQL Database from wherever it is that you're actually completing these exercises. Now, after that, you can see we're going to give you a server name and a location and all that stuff. If I scroll way up, we might be able to see it. Maybe, yeah. So here you can see the name of my Azure SQL Database logical server. You can see where my resources are going to be deployed. And you can see the name of my resource group and all that sort of things. Now, the next piece of code is essentially going to clone the repository, which we'll take a look at soon. And then it's going to create a deployment based on all of those different things that we have provided. We're going to create a firewall rule to Azure SQL, and we're going to allow Azure services access to that Azure SQL database. And the reason for that is so that Azure functions can actually access the Azure SQL database. Okay, so this takes, about 5 minutes or so. So I just went ahead and did it before we started, but you can see all those resources are being deployed. And we can also see the IP address of that Azure virtual machine, so we can connect to it from right in here. All right, now, since you didn't get to see that, I wanted to actually show you in Portal what we deployed. So what we have is we have some app insights, so we can monitor a few things that are happening. We have an IoT hub like we talked about. We're using log analytics to gather some logs so we can see how things are going in the Azure Function. We have our IoT simulator virtual machine, and we have our Azure Function, and these are kind of the main pieces of this. But it's pretty nice, don't you think, Davide? You just click a few buttons and there you go.
Yeah, I always love to see, all this stuff deployed in a bunch of minutes in this case. And man, it makes life so easy that I can even say it. Yes.
Yeah. I definitely hope this encourages folks to like go get hands-on. Okay, so now what we're gonna do is, this is where I stop. So now we have to do everything together and hope it works out. But now what we're gonna do is we're gonna switch from PowerShell back over to Bash, and I'm going to connect to my Azure SQL Database server and essentially run this script which deploys the schema for me. So again, just trying to make things as easy as possible.
Yeah, in the meantime you do it, I just want to add that deploying a schema in that way, it's one option. There are at least other 2 or 3 using, for example, DACPack or tools like DBApp. So here we are just, I guess here we are just trying to follow the easiest possible route, just, to make easier for life for, who never did this and to exactly understand all the moving pieces.
Exactly. Yeah. I mean, I think you could probably spend a long time going through all of the pieces, but I think the goal for this is just to show you how to get hands-on and show you all the pieces, and then you can spend a lot of time understanding how they all work.
Stuff, yes.
So the next thing that we have to do is essentially we have to grab a bunch of connection strings from all these different services so that the Azure functions can access them. So think about it. Azure Function has to be connected to IoT Hub, and it has to be connected to Azure SQL Database, and it has to be connected to a storage account. So a lot of moving pieces. So what we're going to do in the configuration, and again, this is just what the template deploys, is we're going to have to go in and configure a few things. So you see a lot of connection strings here. The first one I'm going to update is the SQL DB connection string. So I'm just going to go in there and update it with my connection string. And then I also need to update the storage account. So let me grab that connection string. Again, doing it live always has a risk. And then the Event Hub connection app setting. So maybe, Davide, while I'm doing this, you can tell them, because you mentioned it earlier, how Event Hub and IoT Hub are kind of similar.
Yeah. In the sense that IoT uses Event Hub behind the scene. So basically, Event Hub is a way, in general, to ingest a lot of data, events, and basically giving the consumer to the ability to kind of consume the event, in the order they were generated, most likely, and of course this becomes very useful for IoT Hub. So IoT Hub wraps Event Hub so that beside storing events in the Event Hub and making it available to Azure Function, Stream Analytics, any other consumer down the stream, you can also manage the you can also kind of communicate with the IoT device, manage the IoT device, and do all the typical, tasks that you probably need to do when you have, a fleet of devices that you need to manage. So, for example, sending action, querying for specific properties. So it's pretty interesting.
Yeah. Awesome. Yeah. It definitely makes it, and it's nice for me because I don't necessarily have to know how Event Hub works, and it just works with IoT Hub. So once we have all our connection strings in, the next thing we're going to do is get the publish profile for this function app, and that's essentially like the connection string to the Azure function. And then what I'm going to do is, you can go out to this code sample and you can fork it. You can see I forked it already, and in the settings. So we're using GitHub Actions here to essentially deploy the Azure Function code. So what I'm going to do in here is I'm just going to go in and update this secret to include our publish profile from our Azure Function app, which again is like the connection string. And then I can go into Actions, and I'm just going to go ahead and re-kick off this workflow because I used it yesterday. In the exercises, you'll essentially go edit one of the files, and that will kick off the deployment. But Davide, you've also done a lot of space with GitHub Actions and CI/CD. What do you think of this process?
That's super nice. As a developer, as you said, I do my changes, check in, push the commit, and basically the GitHub action will start automatically and deploys whatever is needed to deploy. So, for example, if I really want, and that I can deploy everything from the GitHub action. I can deploy the function. I can deploy Azure SQL. I can deploy literally the entire solution. So, in theory, I could change the script once the repository if I fork it, so that as soon as I check in something, everything is rebuilt and deployed again. So super amazing, honestly.
Yeah, it's definitely really useful, and it
it
also
saves
just
so much
makes
time. Yeah,
it just takes a couple minutes, but that's okay. We can go ahead.
yeah.
So the next step we're going to do is, again, I don't actually have 1,000 trucks or thousands and thousands of trucks. So we're going
Yeah, that
to.
would be nice to expense, like, to the manager.
Yeah, by the way.
Yeah.
So what we're going to do is we're going to connect to this Azure virtual machine. And since I'm connecting to it for the first time, just making sure it's all set up. And what we're going to do is we're going to use containers to simulate the different devices. So what I'm doing right now is I'm just going through and downloading Docker. And then I'm going to install Docker.
Yep.
And then once it's installed, we have this really awesome set of simulator device provisioning containers that you can use to kind of simulate IoT activity. So it's really cool. It allows you to set up things like you can see like the different values. So it's an engine on or off, the range of values that come out. So 90 to 80, even the interval and the number of devices. There's a lot of stuff in here so you can kind of simulate workloads without having one.
In the meantime, it's deploying. I guess what you're showing is also really shows the power of Azure, because you're using Windows and virtual machine and Linux and Docker and GitHub and all together, but in a very seamless way. That's what I like, right? So you don't even have the feeling that you are changing operating system, platform. It's all integrated, and that's exactly the experience as a developer I love to have. I just use the best tool for what I'm doing, no matter what the tool is, like GitHub or Linux or a Docker container, and so this makes me super efficient, super productive, right? So this is really, really nice. And the fact that I can do it from this sandbox, wow, that's very nice, because I can follow all the tutorial on one side and immediately play it on the other and see the results. So that's pretty interesting. And
I think what's also cool about this one, and kudos to the team as we built this, is that you can do everything except the Power BI, everything in a browser. So you notice I haven't left the browser yet.
Yes. Yeah, no, that's nice. So really, I even with anywhere I am, even if I don't have the most powerful computer on earth, I can just use the power of Azure, which is great. And look, messages are starting to be sent, so that's pretty nice.
Yeah, pretty cool. So now what you can see is we're kind of simulating these messages being sent, and what we should be able to do. Sometimes there's a slight delay in being able to monitor this, but what we should be able to do is go into the Azure function and see that this is actually coming through. Let me just see if we can get it to refresh. Do we have any other questions that have come in the meantime, Davide?
Yeah, unfortunately, I don't see. There's some glitch, technical glitch, so I can't see the question, unfortunately. So cannot help here. I'm sorry, very sorry, but yeah.
No worries. It looks like there was one. Maybe you can take a stab at it. It said, this is kind of a complicated question, so I'm not sure if we might have to take this one offline. But it says, when is the best time to use message routing to built-in endpoints in IoT Hub? And can we have an example for using message routing to built-in endpoints versus Azure Stream Analytics? We might have to take that one offline. That's okay.
Yeah, even because I did quite a lot of IoT, but not super recently, so I'm not familiar with the latest updates of the IoT app. Yeah, so maybe we can just take that offline, because I know quite well Azure Stream Analytics, but I'm not that familiar with the message routing to built-in endpoints. So yeah, I prefer just to do some research before.
Okay, sounds good. So what we see in the Azure function is we can actually see that this function is being triggered. We can even see, if you can see when it pauses, some of the values that are coming across. So you can start to see this is working. And the final thing for us to confirm that this would be working would be to go into the database and see if there are entries there. So,
so what we are seeing, just to make sure that everyone understand, let's say that we have a fleet of trucks. They are sending data, and what you were showing before in the Azure Function are actually the data coming from the device. In this case, they are simulated, but actually that would be the real data, right? That's pretty cool.
Yeah, exactly. So let me see. So, and again, all of this is documented in the exercise. Sorry, what were you going to say, Davide?
Oh, no. Now I'm looking forward to see everything in Azure SQL. And, so basically the Azure Function is sending data to Azure SQL right now. So I guess that as soon as...
usually it runs very fast. Let me just see.
Yeah, here we go.
It's a lot of data coming in.
That's perfect. Yep. Yeah. So IoT device sending data to IoT hub, that offload the data to Event Hub, that basically Azure Function picks up the data, do some processing, send it to Azure SQL. Beautiful.
Yeah, exactly.
Love it.
Awesome, cool. Okay, so let's get back to slides. Hopefully that was good for everyone. I want you all to see if you were paying attention. Davide, we'll see if you're paying attention. And we'll do some knowledge check questions. So where you're streaming from, you should be able, if you're watching this live, you should be able to answer this first question. Let me just see if it's showing up so I can see your answers. But this first question is, in the typical IoT solution mentioned, what is the purpose of warm storage? So Davide, you had talked about this earlier.
Yep. So do you have any answer? Or,
looks like
I can't help.
The answers are starting to come in, but I think maybe if you want to take a process of elimination approach, make it easy
so
for
let's
folks.
start with A. So optimize storage for large volumes of data at a reasonable cost. That sounds more Azure storage to me, right? Azure SQL is good for large data, but definitely Azure storage is cheaper if you don't have to query the data. So maybe let's put this aside. Perform real-time streaming for capturing low latency events. That's probably more for stream analytics, just, even just because of the name. Persist low latency events and messages that need to be ingested efficiently at a high rate. That could be. Let's see the last one. Manage bidirectional communication. That's obviously IoT hub. So I would say C. Finger crossed. Woo! Okay, I was waiting.
Nice.
That's exactly what we are doing, right? So that's pretty cool. And
well done, Davide. I was just going to throw up the second question, but for folks who had answered the first question, it looks like people were pretty split between B and C. So again, the perform real-time streaming for capturing low latency events. That would not be a storage scenario, right?
Right. Yeah, I guess that could be maybe someone kind of interpreted like where you park the data so that you can also do some other processing. But yeah, probably the most correct would C. B could be something maybe, someone perceived as correct, but C is better. Yep.
Awesome. Cool. Okay, so let's try one more. Hopefully this one we have a little bit better success rate. This one is, what is the advantage of using Azure SQL Database for IoT scenarios?
I feel confident here. So Azure SQL Database can ingest millions of events per second, yes, while querying ingest data with sub-second latency, yes. So probably A. Well, let's go also with the B and C just to see if they are completely wrong or what. Azure SQL Database can integrate with other services, yes, including Azure Function, yes, and Stream Analytics, yes. That's interesting. So A and B are both good. So let's see the C. Azure SQL Database supports real-time analytics. Yeah, you can configure up to 30 read-only replicas. So all of the above, I would say.
That's what you think?
Yeah.
Are you sure?
I don't need to cross my finger. I'm pretty sure. Yeah, they are all. Yes. Let's see.
Yes, that is correct. And for our viewers, I wasn't really able to stump anyone A few of you only said C, but most of you said D. So don't forget, Azure SQL Database can do a lot more than just real-time analytics.
Yeah. Oh, yeah, yeah. Much more. Absolutely.
Okay, and speaking of that, one of the answers to this question was ingesting millions of events per second. One thing I wanted to talk about is how you can actually ingest a ton of data at once. And I know there are different patterns, and there's one pattern that I've heard of called the shock absorber pattern.
Oh,
I was
yes.
wondering if
That's
you
very
could
nice.
tell us a little bit more about how that works.
Yeah, absolutely. So it's called shock absorber because basically you have a massive amount of IoT devices, or in general connection, but for this purpose, IoT devices connecting to Azure SQL, but really a massive amount, like hundreds of thousands, millions, trying to write on the same table. And in order to do that, in order to keep up with all that volume of data and concurrency, you need to use something called the memory optimized table, where we are able to basically keep the data in memory, don't use locks to allow super high concurrency, so you can really write super fast into this table, like millions of rows per second, literally millions. But then, of course, this table, as the name implies, it's memory optimized, means that it needs to live in memory, right? So of course, memory at some point will, will end. It's not that we have everyone has terabytes of memory available. So what you need to do is basically offload maybe the oldest data stored in this table into a disk-based table where you don't have the cap imposed by the memory available. And then basically use this table just as you say, a shock absorber, because it absorbs the shock of 100 or even millions of device sending data. It acts as a buffer, and then you can, using a scheduled approach, using Azure Function, for example, or Databricks, or whatever you want, you can take data out of the memory optimized table and move it into another table. Probably you want to move it into a column store. So you use this technique just to make sure that even when you have a huge amount of spike workload, you can still easily manage it without generating timeout exception or any kind of other error to the IoT device. So that's pretty nice. And that's why it's called the shock absorber pattern, because it absorbs the shock of the massive amount of data coming in.
I love it.
Cool. Yeah.
Davide, like, as a SQL person, and anyone who's watching this that considers themselves a SQL person, like something like column store is very familiar. But for people that are maybe a little bit newer to SQL, can you talk a little bit more about column store indexes, and how that relates?
Absolutely. So column store is, first of all, Azure SQL is amazing in how we implemented the column store, because it not only allows to quickly aggregate data, and I will explain in brief why it's so quick, but it also allows the column store to be written. Several other system doesn't allow you to update the column store, because as you will see, the column store is super efficient for reading. Writing is not so efficient, but we found a way to make it work very nicely. So that's how it works. Basically, you have a bunch of rows to load, millions, let's say, or even more than millions, probably hundreds of millions. We split the rows to load in groups of, let's say, around 1 million. And then we split the rows that are already being split in groups. Each row is basically take the single column that composes this table. So I don't know, the device ID, the temperature, the data transmitted, in which data has been transmitted, and so on. And we separate all this data into segments, as you can see in the slide. So basically, each column is saved along with all the values in that column into a segment. But this is pretty interesting scenario, because for example, IoT devices have their own ID, right? But even if you have a million of devices, but they send 100 of millions of data, it's very likely that if you just take a look at the device ID column, many values are repeated. So they can be highly compressed. So for each column segment, we actually compress the data using different technique, from run-lang encoding to binary to dictionary compression, and we store that segment into the column store. Then when you need to access, let's say, for example, you want to count what is the average temperature group by device returned in the last 5 minutes, what the engine can do is just read the columns you are interested in. So even if you have a table with 100 of columns, we are only going to read the device ID and the temperature. They are super compressed, so they are super efficient to read. We can take advantage of the most advanced CPU technologies like SIMD and all these vector computation techniques that are actually used even in 3D games. We use it to improve the performance of the column store and quickly return the data using a technique called batch processing. At the same time, as you can understand, this is super efficient for reading because everything is so compressed, but you can imagine that the more compression you add, the more it's hard to write because you have to decompress data,
Right.
and maybe, So what we do actually, we have two options here, but basically we make the column store writable by basically sending all the added rows to something called the delta store. And when the delta store, which is not stored as a column store, is a regular row store, but when it becomes big enough, automatically and transparently, we take the delta store, we do all the compression behind the scene, and then we put it in the column store. So you have kind of the best of the both worlds. You can still write into the column store, and then when you want to query it, it's super fast, and all the challenges of dealing with taking the data from a row store, turning it into a column store happens behind the scene completely transparently. And that's, again, it's nice because it completely offloads this duty from the developer's shoulder. So again, it helps me, developer, to be more efficient. I just have to configure this and that's it. So that's pretty nice.
Awesome. Yeah. And it seems like at least for our scenario where maybe we would want to look at just one truck, for example, it's going to make querying that in real time very fast. Is that right?
Right. Correct. Beside that, you can add on top of this column store index other techniques like table partitioning. For example, you said maybe I want to focus on a specific track. Maybe what you want to do is make sure that all the data that belongs to a specific track is close together, right? It's not mixed with data coming from other tracks. So when you can read one track, you only focus on that amount of data. So you can use table partitioning with column store indexes to basically use all these different technologies to work together to create something that is, again, super fast to write and to read and easy to maintain, I would say also. So that's what I like. Just like I was telling you before that I like Azure SQL because you have, Azure, because you have different technologies that works well together.
Right.
This is true also for Azure SQL. You have several technologies working very well together within the engine.
Awesome. And one more technology that, comes up in IoT, but comes up in really everything these days is JSON. How does Azure SQL and JSON kind of play together?
So we easily manage JSON. As you can see there, and that's typical, right? You have an IoT device, I would say 99% of the case will send some JSON data. Now, for that JSON data, you may have some properties in the JSON that are well known. Let's say in this case, the price, but in our sample could be the device ID, could be the temperature, plus another bunch of properties that may change over time, like depending on the IoT device version, the firmware version, many things. So you probably want to have JSON as a way to transfer data from a IoT device through the cloud into Azure SQL. But then when it's in Azure SQL, you may want to have some JSON properties treated as columns because you want to aggregate them quickly, maybe using the column store. And some other properties stay at JSON because you don't really need to query it. You want only to, report it into your report and show the details of status of the IoT device. So you can do both. You can use JSON as JSON in Azure SQL, or you can use JSON as if it were a table, and that's also true the other way around. Let's say you have a table and you want it to return it as JSON, you can do that too. So by using OpenJSON or for JSON, you can turn a table into JSON or a JSON into table, or if you need, you can just manipulate JSON using JSON query, JSON value, JSON modify. So you really have almost all the option here to manipulate JSON, I would say.
Awesome. That seems great.
Nice. It gives you the flexibility you need when dealing with IoT data that is very, diverse in nature, I would say.
Got it. The other thing I wanted to mention and then get your input on, Davide, is this idea of replicas. So when it comes to Azure SQL Database, there are a lot of different options that you have for replicas. There are geo replicas, which allow you to create readable secondaries in different regions. Then there are also auto failover groups, which allows you to create a failover group to another region, and then you can kind of fail over between if you need, but you can also use that failover group for read-only workloads. Then the business critical service tier, behind the scenes, we're deploying a failover group or an always on availability group, and so you get a read-only endpoint there. And then finally, hyperscale. Then this is a really interesting one because it really scales here. And I know this is something you've worked on. Can you tell us about the different replicas in hyperscale?
Absolutely. So hyperscale is this cloud re-architecture version of Azure SQL, where we still have Azure SQL. So the engine is not similar, is not close to, is the same engine that runs in the business critical or general purpose or even SQL Server on-prem, but it's been re-architected to actually use a set of distributed services to store data. So basically we have the compute node where you actually connect to and run the queries, but the data is not made available right from files, but from page servers that actually can elastically scale out. So that's why it's very easy for us to add more space and more page servers to go up to 100 terabytes, because we separated compute from storage, so each one can scale independently. Now, in addition to that, now that we have this kind of, this technology is now matured over the years, because it's been a while that Azure SQL Hyperscale now is around. We are starting to add more and more cloud born, I would say, or native cloud features. Like, for example, geo-replication. You need to have data replicated into another region for reporting or failover purposes. You can do that. Of course, in that case, data will be copied in the other region, right? So that will probably take a while, but at the end you have two copies of the data kept in sync. Or you want to have additional compute node in the same region, just to say that if something goes wrong with the primary, you want immediately a kind of a warm backup to come up and take the queries and keep the workload running. And that's why we have high availability replicas, because if you need to have 99.99%, for example, of high availability, you can have that too. Or let's say that you are mainly interested, instead of having a lot of different replicas, to allow different entities, be it a human or a machine, read from the data. But you want to make sure that each one reading doesn't affect or use a resource of other entities or person. So for that reason, you want to create a named replicas, where basically you can have up to 30, and each replica can access the data that all the other replicas can access. And this means that you can have one set of named replica being used by Power BI, another set of replica being used by the data scientist with Spark, another set of replica used to push notification to mobile application of people in the truck, for example. All of those replicas are a set of different compute nodes, so they are independent from each other, so you can scale up and out independently. They will not affect each other performance. So that's pretty cool, because when you have millions of data and you have to do report on it and analyze the data with the data scientist and send the data, monitoring data to a mobile device and do many other stuff, it's very important to keep these different workloads separated, because otherwise they will kind of tangle up and that will be complicated. Instead of separating all the workload, beautiful solution, beautiful architecture, and super performant. So
yeah, I've definitely been really impressed by named replicas. And in our scenario, for the truck analysis, maybe we want to do some heavy duty analytics at some point, but only for we only need it for a couple days. So what we could do is on the fly spin up a named replica for our analytics. And then once we do the analytics or we train a model, we can kind of kill that named replica and we stop paying for it. So that's really cool. I think it's just, yeah, definitely super elastic. Now, Davide, are there other things that people should keep in mind when it comes to using Azure SQL Database for IoT situations?
Well, something I already mentioned before, partitioning, because that's especially when you have huge databases like database with trillions of rows, I'm talking, or database with hundreds of terabytes, you really want to use partitioning because we have a kind of trick. Let's say that you partition data by month, right? And of course, if you want to analyze data, probably at least for the solution the IoT solution you are building, you don't really need like the last 10 years of data, right? So you probably need the last year or the last 12 months. And when January came, the 13th month can be removed. But deleting, I don't know, 100 million of rows can be pretty expensive, right? Because we literally have to delete every single row to guarantee you the ability to roll back every single delete statement. So that comes with an overhead. But instead, if you have all the data that is related to a month into a partition, you can drop the partition in a second. Because we basically completely deallocate or remove the pointer that says that the partition belongs to that table, and that's it. The partition is gone from the table. You can move to another table, for example. So it's very easy to do scenarios like sliding windows or reloading an entire partition without affecting the other partition. So partitioning, like in any distributed system that now it's becoming more and more popular, so people are probably more aware of the partitioning needs. Is something that has been available in SQL Server since ages. Now it's also available in Azure SQL, of course, and it's something that if you are dealing with IoT data, is something that you probably want to take a look at. Absolutely. Data compression is another. Because especially when you partition, you probably want to have the super fast access to the latest partition that contains the hot data, like the last 5 minutes data, right? You don't want to have compression there because compression means you are using CPU resources. But you want to have compression when the partitions start to become old. Maybe it's the last month or 3 months ago. So you don't really have to do a lot of insert and update there. So you can compress data. And you can even decide to have different level of compression per partition, depending on how fast you want to be able to write into that data or how much you want to compress it. So these techniques are really, really helpful when you have a very large database that with IoT are usually quite common. Index maintenance, you don't do it. You don't have to do it. In the sense that probably the usual index maintenance procedure that you were used to do for regular solution or on premises doesn't really apply in the cloud database in Azure SQL. So, for example, doing a daily rebuild of indexes or a daily defrag maybe is not the best option. Connor wrote a very nice article on Stack Overflow on how to actually do the index maintenance, if doing it at all, that I would recommend people to read, because it's the cloud is different and requires a little bit of a shift also in what we were used to do as a DBA at some time. So that's interesting.
Right. And for index maintenance, like when it comes to IoT data, like you're expecting the data to be pretty, not static, but like it's not changing a ton, hopefully. So you don't need that, right?
Exactly. That's the point. What's the point of rebuilding an index that maybe takes 2 hours on a partition that contains data of 6 months ago that no one ever touched? Right? Yeah. So there's a different, you can pick and choose, for example, on which partition you want to do the maintenance. But again, index maintenance is it has evolved since the on-prem kind of scenarios. Again, IoT then is even more specific, so it's different than what it was used to be. So again, for static data, as you said, probably you don't want to do it, and even for the real data, let's discuss.
It depends.
It depends.
Okay, with that, let's go for another knowledge check. Let's see how you're doing, Davide, and let's see how our viewers are doing. So if you're a viewer, go ahead and take a look at the question. It should be up on your screen now, and take a few moments to give that an answer. The question here, remember, it's a not question. The question is, what is not a piece of the shock absorber pattern? So Davide talked about this shock absorber pattern and some of the different pieces inside of it. So go through and try to figure out what is not a piece of the shock absorber pattern. Let me take a look. Some of those answers. Do you have thoughts, Davide?
Yeah, so I just want to call out the second because I just realized that I didn't mention that before. I was so excited about the entire thing that I didn't mention something that it's good to have here. Actually, when we write into a memory optimized table, you can actually write a storage procedure that, while it's being written in T-SQL, is actually compiled into C code and run in process. And we need to do that because the memory optimized table are so fast that if we would use the regular T-SQL that is interpreted, that would be the slowest part of the entire picture, right? So we need to compile T-SQL into native code to be as fast as the memory optimized table can be. Just to give you an idea how fast this table can be. So I would say load data into memory optimized table. I guess so. I talked basically for 10 minutes only about that. So, and B, I just mentioned that it's definitely part of the shock absorber. Use JSON support for high ingestion. Okay, let's. JSON is not really needed for the shock absorber, so you may use it, you may not, but it's not like mandatory part. Like instead of it is the memory optimized table. And offload historical data into a disk-based cluster column store index. It's I mean, yeah, also in the slide it was there. So I would say C is probably the part that is not part, in the sense that it's not mandatory. If you want, you can, but it's not that you have to.
Awesome. Yeah. And it looks like most of our viewers got that. So nice work. We're
Cool.
going to go on to the next question. This is one that Davide and I actually went back and forth on what the answer should be.
Yeah.
So this is one
interesting.
you have seen before. So we're going to go ahead and put that one up. So this one says, consider all the Azure SQL Database hyperscale replication options. What is the current maximum number of replicas you could configure for read scaling? So Davide, just since there's a few, like let's go ahead and start listing through these as people answer the question.
Yeah, so 4 is actually the number of HA replica, so high availability replicas we provide in hyperscale that can be used also for simpler read scale out needs. But definitely then we have named replicas that you can go up to 30. So I would say C seems to be the correct one because it's 30 plus 4, it's 45. But you mentioned that GODR is actually another replica, right? So if we also consider all as, and that's the tricky part, I would say, considering all the options we have, if we sum the 1 GODR plus the 4 HA plus the 30 named replicas, you can have 35 replicas used for read scaling, which is pretty impressive. If you think that each replica can go up to 80 vCores, so you probably have several thousand vCores just for your database, which I guess should cover pretty much all the possible, even the biggest customer we can imagine at the moment.
Yeah, I'd be curious to see like a customer that wanted more than this. But
I'd be happy.
Hey, who knows? Yeah, we'll be happy.
I'd be super happy to play with the big tools, but yes.
But to our viewers, I think we really stumped them on this one. And that's kind of what I was trying to go for, just to make sure everyone's paying attention. There are differences. I think most people said B, so that was the number of named replicas possible. And those are probably the best for kind of your read scale type of workloads. However, those 4 HA replicas are available for read-only use. The problem or the challenge with them is you don't control which one you're going to when you use the application intent read-only. And then the geo replica, which brings us to 35, is awesome, especially if you might need kind of some sort of failover or you want to be protected in that sense. However, this one is recommended to be the same compute as your primary. So on all of these, I would say named replicas for read scale is probably going to be the best first option. Is that fair?
Right. No, absolutely. You're right. So depending on each one needs, again, that's the usual, things about Azure. Depending on each need, one pick and choose what they need. If we say in general, what is the best solution for read scale out is named replicas. But again, not everyone needs, the ability to scale independently. Maybe you are happy with just saying, okay, I have a HA replica. I don't have, super complex scenarios. I'm fine reading from that, even if, as you said, I can control it. So I will go in any replica it's available. I can decide to connect to a specific replica, but still for many it's good. So it's all about choices here, and that's what I like about Azure again.
Awesome. Cool. Okay, so let's take a look at the next exercise. In this exercise, you'll get the opportunity to look at the configurations of the database and take a deeper look at some of the options that Davide has talked about, like column store and compression. And then you can monitor the captured events in Azure SQL Database, either using queries or using Power BI. So what I wanted to do is just hop back over here. And you can see we still have a lot of messages that have been coming in, so that'll be interesting to take a look at. But if you go up here to the exercise, the second exercise, what you're going to see, and I'm not going to spend a ton of time here since Davide went through a lot of them for us, is we're going to talk about some of those considerations you might make around things like compression, max stop, using different views for aggregations. So there's a lot in here. Then there's also some things you can start to take a look at, like the latency and the typical data, or how you're using your resource consumption. So instead of going through each of these queries, I wanted to show you in the Power BI file. So you can essentially go and download this Power BI file, and then you can hook it up to your Azure SQL database. Now, what you're seeing here is one that I deployed yesterday. So it has been running for 24 hours. That's why you see so many events. But I wanted to show you this just in case I wasn't able to get our live one working. But what you can see is this is an 8V core database, and you can see maybe we could even scale down. We're not using all the CPU, but we do have 1,000 devices right now, bringing in, I think, 100 readings a second or something crazy like that. So we've got a lot of data coming in. We can see the different engine state, the typical temperature being reported. And you can see how low the latency is. Right now it's very, very low. So now what we can do is, just so you all know how to do this when you go try to set it up with yours, is we'll try to connect it to our Azure SQL database we just deployed. So what I'm going to do, and you'll want to do the same thing, is I'm just going to go in here and I'm going to change that data source. I'm going
Anytime
to...
you do that, maybe I can spend just 1 second on something you mentioned before, like DOP, the degree of parallelism.
Please, yeah.
Yeah, that's something, other kind of fine-tuning knob that we provide. So if you have like an 8V core or a 16V core, normally the query optimizer will try to execute one single query using all the processor, which is great on average if you want to do, like, for example, aggregation very quickly. But in some case, maybe you want to limit that max degree of parallelism to 4 or 8 to make sure that multiple queries can be executed at the same time using different processor. So there are, best practices for IoT, depending if you want to push more on the kind of reporting performance or the ingestion performance. That's one of the knobs that once you have a little bit of experience, you will find very helpful to fine tune, because it really gives you the ability to, again, be in control as a developer and exactly define where you want to push your performance. So that's one of the nice things that once you go deeper into this architecture, you start to appreciate and say, hey man, they really think about that. it's really useful to have this little knob that I didn't even know they exist at the beginning, to fine tune my solution, and that can make a good amount of difference when used correctly.
Yeah, definitely. And I think like going through and looking at the actual ARM template is going to be a valuable learning exercise after you go through getting all the hands-on stuff. But what you can see here is, just in, I don't know, like the 20 minutes since we deployed this, we've already got 4 million events in our data store. We can see the temperature of things coming in pretty stable, no outliers at this point. Actually, it seems like a lot is just the same. And we can see the different latency. Oh, so this is a time series bucket view. So we're actually looking at a 10-minute window. Sorry, I forgot about that. And looking at what the temperature is aggregated at a 10-minute window. But you can also see every single reading coming in. So the readings are actually changing, but overall we're having a pretty consistent. Yeah, exactly.
And that's probably using the column store to aggregate data in buckets. So it's pretty nice. Yeah.
Exactly. Yeah. And if you go through some of the exercise, you can see all those knobs that are being turned, like Davide said, and it's a great learning exercise.
All right. Yeah.
But yeah, this is the solution. And so we kind of thought to put it all together, wrap a nice little bow around it. We talk about 2 customer stories. Davide, do you want to take the first one?
Yeah, this is something that it was a kind of a bit in the news last year because RxR Reality is a kind of estate management properties that they started to use IoT to basically monitor the temperature of people going in their own premises, due to the COVID and the pandemic, and they decided to use basically it is exactly the architecture we described. So they have everything running on the edge, then they connect to IoT Hub, then they use Stream Analytics to the processing. Here they are using something even more advanced, I would say. So out of Stream Analytics, you can even call an Azure function. So in this case, they are using both because Stream Analytics is super simple to completely deal with everything that is time related. If you try to do the solution, you will see that dealing with the fact that we have a stream of data, that creates some challenges that are almost all solved by using Stream Analytics. So for example, using tumbling window, session window, that's something you don't have to worry about. Stream Analytics will do it for you. And then maybe you don't really want to immediately save data into Azure SQL, but you want to take some decision on the data before it lands on Azure SQL. In this case, so they use the Azure function after Stream Analytics, and then Azure SQL is used, for example, to store the warm data enhanced with the result of Azure function and displayed in this case using Azure App Services on a dashboard they have created. So this is pretty nice, and I would say is literally the tutorial, just put in production in the real world. So that's pretty nice.
Exactly. And who knows, maybe they use this template at some point. I don't know. The other customer we want to talk about is Verse Technology. Now, I thought this one was interesting because if you watched the keynote this morning from Satya, you heard about Grupo Bimbo, which is I'm sure I pronounced that incorrectly, but that is a baking manufacturer full of factories, and Verse Technology worked with them to essentially help them convert over 15 factories at this point into these kind of more smart connected factories. And they're using Azure SQL Database, very similar to how we saw in the tutorial, but instead of Azure Functions, they're using Stream Analytics. And with that kind of brings our session to a close. I just want to remind you all that we discussed how to create scalable IoT solutions using Azure SQL Database. And you also got an awesome template, which you can go try for free, which we hope that you will. For any use case. What's that, Davide?
No, right. Let's go and use it because the work we have done behind this, and what this enables you to do in a very few amount of time. It's amazing. So absolutely go and check it out.
Yeah, and we did get one question. This is the question we are trying to understand more and more how to answer. This question is, so is Azure SQL more recommended for IoT warm storage than Cosmos DB? You want to take a stab at that one?
Thank you, Anna.
You're welcome.
Well, again, the point is I think the answer to this question is what you are most comfortable with. You can use JSON in Cosmos DB, of course, that's native, but or in Azure SQL. Then you need aggregation. You are already proficient with T-SQL, then go for Azure SQL. You need maybe to separate the IoT data from the analytical data. Maybe you prefer to use Cosmos DB and Synapse. I don't think we can say there is literally one best solution here, in the sense that they all give you the possibility to build what you want. It really boils down to what you need to do, what you know, and what kind of other thing you plan to do in the future, right? So maybe you are already using Synapse, go for it. Maybe you are already using Azure SQL, no need to spin up a completely new database that maybe you don't know, right? So it's almost impossible to say always do that, because always it's hardly correct, given that
right.
Azure provides services for so many different workloads. Yeah, it's impossible to say. So use whatever it makes you happy, just like Scott Anselman says. That's it.
Love it. Thanks, Davide. I know that's it's a fun
That
question
was
to answer.
tricky.
As we wrap, I want to remind you all that Learn Live doesn't just happen during Ignite. Actually, the Learn Live team is doing a module Davide and I created in December, Architect Modern
Yeah.
Applications using Azure SQL Database. So if you had fun today, you'll probably have fun in that session as well. So just go ahead and check that out. You can scan the QR code to register, I believe, although it will be streamed live on Learn TV. And of course, some resources. Check out this Microsoft Learn module, or if you want to go straight to the GitHub code sample, you can do that at aka.ms/Azure SQL IoT sample. We try to keep it simple. And if you go to Azure SQL YouTube page, you can see a lot of things that Davide and the team and I do together through Data Expose. We release episodes on Thursdays about all things Azure database related, as well as lots of live shows. And with all the announcements going on, you're definitely going to want to tune in to our next news update so you can get the latest news. A few last things. Don't forget, oh yeah, I already mentioned this. Don't forget that Learn Live happens all the time, not just at Ignite. So you can see all the episodes at aka.ms/Learn Live. And the final thing I wanted to mention is the Cloud Skills Challenge. So don't forget to sign up for this. If you complete it, you'll get a free certification.
Wow.
And so thanks so much. Davide, I think that's all the time we have. But thank you, and thank you to our viewers.
Yeah, that was amazing. I hope the people who connected today enjoyed it, and they just go and now play with it because it's super fun.
Awesome. Have fun, and thanks so much for joining us on Learn Live.